Hey, all right. Hi, everyone. My name's Lachlan Barclay. I'm a .NET dev, been a programmer for about 20 years. I worked out the other day, which is crazy. So if you're young, be careful. It sneaks up on you. I don't know how it happened. Suddenly I was a senior dev. Crazy. Anyway, so I'm talking about, high performance C# code with Visual Studio's Profiler and a bit of benchmark.net thrown in. So what I wanted to talk about was, the problem that I had was I work on an application that has to do a calculation for every time you change something. And currently it took it took about a second to calculate, which is fine. Users don't really care about that. And then the next day, my boss said to me, oh, we run that calculation to calculate the results. We actually want to run 2,000 of them real time so we can do a simulation and we can average them all out and we can give somebody a measure of confidence. Can we do that? That'll be easy, right? Just go ahead and do that. So thought, okay, great. I'm gonna have to see if it's possible to optimize this thing. And I didn't write it as well, which didn't help. Not that it would have been any better if I had have written it. But I didn't write it, so I didn't understand it all that well either. So I did what I hope most people here would do: Google it, how to write fast C# code. The first one that came up is this really great article written, it's up on MSDN, it's really old. It's called Performance Best Practices at a Glance. Whoever put in the phrase "at a glance," they were being a little bit cheeky, because even the overview takes 37 minutes to read and one chapter takes 2 hours. So that's not my definition of a glance. But those articles are really good. There's heaps of great info in them. I should have put that up. If you want to, you can just Google it, it'll come up, or you can go to Performance Best Practices at a Glance. I think I got that acronym right. But yeah, they're long. There's lots of info and it's really easy to get overwhelmed. I was. So talking about being overwhelmed, here's some more books on .NET performance. I've read the one on the left. I haven't read the one on the right, but apparently it's meant to be really good. The one on the right is written by a Microsoft guy, I think. The one on the left is a little bit old, but it's still pretty good. But the problem that you have is you can read all the books, you can read you can have all that knowledge of what is actually slow. But for your application, working out what's actually slow, the books don't really tell you much about that. They just say, don't write code like this, write it like this, this is fast. Don't write it like this, write it like this, this is fast. And so working out sort of where to start is the next challenge. So I'm sure everyone here can probably work this one out. I've got 2 bottles here. Now the one, it's confusing. The one on the left is actually being held in my right hand, but it's on the left. So both bottles have actually got the same amount of water in them. And what I'm going to do is I've made an amazing animated GIF, and I'm going to pour them both out into the sink at the same time. And you guys have to use all of your amazing brain power to work out which one will empty first. So take a guess. Doesn't take a genius to work this one out, but hopefully this works over Zoom. Big surprise, the one on the left came out, took a lot longer for the water to come out. Exactly. So the reason why it took so much longer to come out is because there's a bottleneck on the bottle. That's the phrase bottleneck you might have heard, but that's what you're trying to do when you're trying to performance tune a lot of the time, is find out there'll be one little bit of code that's slowing everything else down. And if you can find that, you're in business. So you want to be like the thing on the left. Your code is like the water coming out. Amazing analogy. So finding the bottleneck. Let's do it. I'll tempt the gods and try to do a live demo. If it doesn't work, it's not my fault. It's Visual Studio's fault. So here's some code. No trick question. I'm going to try to tweet this. Let's see if this works. Where's my mouse gone? There it is. Let's try to do a real-time poll. I was hoping we could do this inside Slack, but I couldn't figure it out. If you go to Twitter, my username is Rhok. Have a bit of a stab in the dark. What do you think will actually be the slowest? So this bit of code here, it's looping through 10,000 people. and it's fetching one out from the database. Not sure if you guys can see my mouse, but there it is. It's getting a person. It's calculating an MD5 hash for that person, which is no longer secure, by the way, so don't rely on that for anything. It's appending that out to disk, and then every 100 people, it's printing out to the console that we're doing something. 0 votes. Why don't we just post it in the chat? That might be a bit easier. I'm trying to get Twitter happening. Has that tweet appeared? Is this going to work? Hey, you have an answer. Okay. Okay, so why don't I actually have a crack while we're doing that? I'll actually do that in Visual Studio. So here's the program in Visual Studio. Thanks, Ben. There's a tweet. There's a link to the tweet there. File.append, a couple of people are saying, trick question, absolutely. That could be happening. It's not a trick question, though. All right, so to launch the profiler, we're going to performance profiler. Now, confusingly, it's under the debug menu option, but when you're running the performance profiler, your code has to be a release compile. So it confuses you every single time because you're going, okay, hang on, I was just writing code, I was debugging it, I want a performance profiler, I got to change the release mode, and now I've got to go to the debug menu, go to performance profiler. It's so confusing. Maybe that's just my brain, I don't know. So we're going to go to the performance profiler. There's an option by default, I think. I've enabled CPU usage, and what this will do is 1,000 times a second, it will have a look at my program and store where it's currently executing. This is as best as I understand it, something like that. So if we say start, that will kick off the program. And the reason why I've done 10,000 of them in a loop is because it gives a performance profiler a bit of a better idea of sort of what's happening and what might be slow. Beautiful. Visual Studio, the performance profiler, sometimes it doesn't start, sometimes it doesn't stop. If that happens more than once or twice, just restart Visual Studio and then you'll probably be all right. But often the first time it runs, it just hangs, and when your program finishes running and it tries to collect the result, it hangs again. But that's okay. It's good sort of once it's kind of going and you're in the cycle of it. So we've got our results. So let's go to here. Now this UI I could do with a little bit of work. I have to go to load module symbols, which contracts the tree again. Now I have to expand it, and then I have to double click on it, and then I'll finally get the results. There we go. So get person. There you go. There was the answer. But it sort of was a little bit of a trick question, sort of, because I'm running this on my laptop, and I lie, this is on my desktop, and I'm computing MD5 hashes. I'm dumping stuff out to disk, and I'm fetching someone from a database. And depending on my computer, any of those things might actually be slower than the other, and depending on how I'm doing them. So it's kind of it's a pretty good guess to say, yeah, appending to disk is normally pretty darn slow. But even more confusingly, the profiler seems to think that checking to see if person is not null, it's spending 27% of its time doing that. Now, I can't believe that to be true, but that's what it's showing me. But if we do have a look, now I don't think I can make the text at the top bigger. I can't. But we can see that it is spending 26% of its time calling get person, and it is spending 25% of its time saying append all text. So it gives us a pretty good idea that if we optimize this get person function, we'll be able to get rid of that bottleneck, realize that's a part of the app that's probably slowing it down, and then move on to the next problem and speed it up. But there's another problem here, is that bottleneck only really only tells us the one part that's running slow, and it's all relative. Yeah, Ben just posted something, that null check, maybe it's optimizing it. It could be, because when you do it has to be a release compile to do a performance profile, which means it has all the optimizations. So maybe it's just gotten a bit confused in the lines, which is a little bit disappointing. There's another performance profiler, I think it's the JetBrains one, that's meant to be really good. I haven't looked at it. I don't know if anyone else has had any experience with it. Hopefully it doesn't do this. All right, so where was I? So yeah, there's another problem here in that it's only telling us relatively what's faster and what might be slower. So I took a screenshot in case the demo didn't work, and you can see it's spending 40% of its time calling getPerson. But we don't actually know overall how long the whole thing is taking, and we don't know how long that's taking. We can take a bit of a guess compared to everything else. You can see if it's spending 40% of its time. We know how long it's taking overall. We can probably calculate it, but it's not a really good way of knowing exactly how long it will take. So you can, let's skip all that. Okay, so you can just time it yourself. You can, pull out a stopwatch and time it, run it a bunch of times. You can create, there's actually a class called stopwatch that's a really good timer. But you run into a whole lot of other problems. So you have problems with the optimizer, and you have problems with if you run it once, if your computer does something in the meantime, you'll get skewed results. Like I've got 10, 20 different programs running on my computer right now. And if it happens to be doing something when I'm running that performance profile, I can really skew off your results. And if you're trying to rely on it to work out what bits of code is what's faster or what's slower, it's really easy, unless it's really, really obvious that your code is spending 90% of its time on one line. As soon as you start dealing with really low percentages and everything's pretty even, you can start to lose your brain a bit, and you start to go, oh, it's spending 8% there, 6% there. I need to optimize that 8%, but it might have been a sampling error. It's not a good way to rely on it. So Microsoft have brought out this NuGet package called benchmark.net, and they use it for benchmarking everything for all of their own internal code. So for Roslyn, for the framework, for everything I got listed down here. Oh, is it not a Microsoft product, Dave? Do you want to jump in? I thought it was.
No, it's part of the .NET Foundation, but it's not Microsoft. The two main guys who work on it, one of them now works for Microsoft, but didn't when he started. The other guy actually works for JetBrains.
There you go. Yeah, but it's a great library, and it takes care of all of those issues of it isolates it in its own process. It runs it lots and lots of times, and if there's one that was really slow, one that was ridiculously fast, it just discards them. And it's great for you to do lots of little tests of what's fast and what's slow. So it's as simple as this. It's really great. It's really, really easy to use. You add the package, you add your code that you want to benchmark, and you add an attribute saying benchmark this, and you say go, and you run it. Why don't I give it a crack? Let's do a second demo. So startup project. Now, I know I said before, when you're performance profiling, you need to run it as release. When you're running a benchmark.net benchmark, you need to run it as release, and you also need to make sure you're not attaching the debugger. So I just hit Control F5, but it's really easy just to go F5 or run it in debug or run it in release and attaching the debugger. And either way, I think it might throw up a warning now, but yeah, you got to make sure you're doing that. So start without debugging release mode under the debug one. So this takes quite a while to run because it's loops through that code, and it does it a whole bunch of times, and it sets up a whole lot of fancy things. And eventually it will tell you how long that function took to run. Now, I think in this example, I'm running it against two different code samples. While that's running, why don't I just bring those up So it's the old classic case of, now we could do another vote here. We can if we want. No, let's not. So we got one method that's looping through a bunch of people and it's compiling up a string, everyone's favorite. And then we also have another function that's using a string builder, looping through the same list of people and appending a string builder and returning the string. So they both should be turning the same result. One is just joining a bunch of strings together and one is using a string builder object. And I think that now that I'm running Zoom and sharing my screen and trying to do everything, my computer is running really slow. So it's going to take a long time to run. All right, there we go. Okay, so I think it's finished running the first one, and now it's doing, there we go, a second one. Summary, let's zoom in a bit, make sure it's readable. Summary, there's my computer. Now on this computer, string concat took on average took 1.1 seconds. Oh, sorry, the mean, 1.1 seconds, and string builder took 200 milliseconds. Yay, wow, who would have thought string builder is a lot faster? But what's really cool and what I love is allocated. That is fantastic. So there I'm allocating 2 gig of memory just by looping through, was it 10,000 people? I can't remember how many people, but that's crazy. So it's a really, really nice way of setting up little samples of code and trying to work out what's faster. And if you start reading those articles of how to performance optimize your code, you'll start to see things like don't use, like, what's a classic example? The list collection is a really heavyweight collection. And if you're pulling back 1,000, 100,000 records from a database and chucking them all in a list, it'll use up a whole lot of memory. And there's a lot more lightweight collections that you can use, or you could just loop through each one as you pull it out of the database. And you can quickly just whip up that code and chuck it through benchmark.net and see how long it takes and get a really, really accurate picture of how long it takes to run. Now, sure, it only shows you how long it takes to run on my machine, but I know that if I'm going to concatenate 10,000 strings, it doesn't matter what I'm going to be running it on, it's always going to be a whole lot faster using a string builder if I'm doing a lot of strings. And what this also means is that you can set up some tests. So if you run these on as part of your build, if you run it on your build server, you can get a bit of an idea how long your code takes to run. And then you can set up, you can say, okay, I reckon my main calculation logic takes, I've worked out on average, it takes about 500 milliseconds. I don't want to accidentally screw it up. So I can benchmark it on the server, and then I can create a test saying, okay, if it takes longer than 500 milliseconds, in this case, 200 milliseconds, fail, throw me an error. I've slowed down the code too much. I've stuffed it up. Of course, this might be a problem if on your build server, you've got heavy load and it runs a lot slower. Maybe you want to run it on another isolated machine if performance measuring really matters to you. It's a really nice way of capturing these performance problems before they get to production. I know this is the list that sort of everyone wants. Yeah, shut up, Lachlan, just tell me what's slow. How do I make stuff go fast? What's slow? So here's the 5-second version. Reflection is really, really slow. Exceptions, horrifically slow. Don't rely on exceptions for program logic. Reflections are really slow. In general, anything that's touching anything over on the network, disk access, network access, database access, really slow. Disk access, writing to disk, probably the slowest thing. The garbage collector uses a, if you've got lots and lots of objects you've allocated, I'm doing lots of hand waving today, that you've allocated all in your memory and it needs to go through and clean them all up and count the references, that can really slow down your machine. And then, yeah, heavy collections and all of that. But bear in mind, it's sort of easy to lose your mind a little bit and to get stuck and get tunnel vision and get too stuck into, oh, I've got to optimize this code. It has to be awesome. Premature optimization is just evil. And when you start optimizing code before you know that you need to optimize it, you can end up with a mess, or you can end up with code that's really, really difficult to understand and maintain. So it's a constant trade-off. And you see a lot of the real hardcore talks of how to, write heavily optimized C# code. And you see, this is what we started with, and we've ended up with this much code. And it's just unintelligible to someone who's not a hardcore programmer. So you've got to constantly go, hang on, am I losing my mind? Is this a good idea or is this a bad idea? Is it still maintainable? Is it understandable? Is it readable? And the other thing to remember, if it's a memory problem, you might just be able to throw more memory at it. If your thing's running slow, spend the money, you get a bigger, faster CPU, it'll run faster. If that's what you need to make your thing run fast, why are you killing yourself trying to write awesome code? You can just throw money at the problem. It might help if you have the money. And you can really just waste your life, and you can lose your mind trying to optimize stuff. Don't do that. So I've started running workshops on profiling your code and optimizing your code. This is kind of the stuff that I'm covering. I'm definitely no guru in all this stuff. I've just been doing it for the last couple of years, so happy to help people out. And I should mention the other workshop I've started doing is porting your code from framework to core, because that seems like that's a big need at the moment. And the approach that most people seem to be taking, every article seems to say, just do a whole rewrite, problem solved. Here's what's different in the two APIs, do a rewrite. But there's lots of clever ways you can go about it to slowly port your stuff across, which is what will hopefully save you a lot of pain. I think that's it. I haven't been looking at the questions. I've been trying to, but I can't really read and talk at the same time.
No worries. I had one actually just now that I've just typed in. Also, here's a saucepan of onions. Any real world examples, any great, like any good wins you've had, or just any cool, something you may have come across in the wild?
What comes to mind? Yeah, there's lots. We've definitely managed to get that main calculation that I was talking about right at the start. Me and another guy have really managed to optimize the thing so it's really quick. We reckon we can do 1,000 calculations in 2 seconds if we max out the CPU on the production server, but we should be able to scale it out. A lot of the things that helped, it's really hard to give advice because everybody's code is different. Everybody's code is doing different things. I noticed that a lot of the time I was doing for each and looping through a collection, which creates a new instance of whatever I'm for eaching through, changing those to use an array and just indexing through it. Saves a whole lot of memory, runs faster. Not quite as nice, but in performance critical stuff, it makes a huge difference. Yeah, it's crazy. Really simple stuff like that. There's another really handy tool in Visual Studio. If you're dealing with code that you haven't worked with much before, when you run the performance profiler, you can set it up to say, why don't I just open it up? And I think for this one, it has to be in debug mode. So I go to debug performance profiler. There is instrumentation. So this is really cool. All this will do is run your app. Why don't I give it a crack and see if it works? I've got to do that. Okay, I can't be bothered doing that. It'll run your app and it'll tell you what functions are being called and how often. So if you're dealing with a code base that you're not very familiar with, and there's lots of stuff going on and you don't have a good idea of what's happening and where, it'll just go through and say, this function has been called 3,000 times, this function has been called 20 times. And if you think that this one's should only be called 10 times, but it's been calling 30,000 times, there's your problem. That's really helpful. And the memory profiler in Visual Studio is really cool as well. I didn't cover that, but why don't I do a quick demo of that? So I think that's really cool. Set a startup project. So if I actually change that to debug and run this.
If anyone's got other questions as well, just raise your hand the reactions area, and I'll get you on.
I'll just show the memory profiles. That's really cool as well. So I can take a snapshot of my app. So currently my app has 1,400 objects in memory. I can go, there we go. That's what's using up most of the memory for my application. Dictionary, which has got a string and objects in it. But then what I really like is I can run it a bunch more times, take another snapshot, and it shows me, oh, there we go. I've got 108 more objects that have been allocated. And I can even look at them. It's really cool. That's great if you're, once you start looking at what data's actually in memory and you're expecting it to be staying the same or going up and going down, you've got all the detail there. Anyway, I could talk about this all day, so I'll stop.